Hey 8th graders, we're going to take notes on pure substance vocabulary. I have 4 words for you with their definitions and their examples, so grab your notebook. Alright, you're going to make this little chart with word, definition, and example. This is the only thing that is going on that page, so take as much room as you need. Alright, the 4 words are pure substance, element, atom, and molecule. A pure substance is something that cannot be separated any further. It is the same. It's uniform. It looks exactly the same thing, and it is the same thing. You can't separate it. An example is pure water, not tap water. This is wrong. So tap water has that stuff that comes out of the pipes. It has it goes through all the rocks down underground, and it goes through a water treatment facility, and there's a bunch of stuff in your water. So if it's totally pure, then that is a pure substance. The next one is element. An element is the simplest form of matter. It's made of only one type of atom. It's all the same thing. There's only one thing, and it's all of the same element. So this would be anything on the periodic table, such as carbon, calcium, zinc, oxygen, bromine, sodium, any of that kind of stuff. Here's a picture of the periodic table. Everything that is on here is a pure substance. It's totally pure even when it's just linked to itself. That's a pure substance. You can't break them down to anything else. It's all one thing. So, for example, they have all these different groups that have the same characteristics, and they're laid out in this periodic table. So over here in the red, we have the alkali metals. These are all shiny, soft, they're super reactive, and they like to clamp on and bond with other elements. Here in the yellow, we have the transition metals. These are good conductors of heat and electricity. So we have these in our wires, and we have these in our pipes. So the water or whatever we're trying to carry with the pipes stays hot. We can bend the metals into shapes and form wires with them, and they have high melting points. They're very soft. You could cut these with a knife. The post-transition metals here in the green are solid under normal conditions. They have a high density, so they seem very heavy when you hold on to one in your hand, and they have lower melting points when compared to the transition metals. The metalloids is the stair step that is here, right here. So these here are the metalloids. These are very brittle. They like to form alloys. So that's when they're combined with other elements to form a stronger metal, like steel, and these are solid under normal conditions. These light purple ones here are halogens. These are reactive. They form acids when they are with hydrogen, and they form salts when they are with a metal. And the last one here, noble gases. These are not reactive. They like to hang out by themselves. They bond just to themselves and hang out in the air. They're gases under the normal conditions. They're colorless and they're odorless. Here's another picture of the periodic table showing things that are made with that element or where you find it. All right, the third word is an atom. This is the smallest particle of matter. It's made of a nucleus here, which has the protons and neutrons, and then out here in the clouds, they call them, are the electrons. So an example of an atom would be anything on the periodic table of elements. It's only made of one atom, so if this atom has 6 protons, 6 electrons, 1, 2, 3, 4, 5, 6, then this is carbon. All of the different elements have a different number of each of these 3 particles. So one atom of carbon looks like this. When you have a whole bunch of carbon of atoms and it's pure carbon, that's when you have an element. So an element is an atom, but an atom, we talk more specifically about these 3 particles. The last word is molecule. This is when there are 2 or more atoms that are either the same or different that are bonded together. For example, if they are the same, that would be oxygen. It's 2 oxygens that are bonded together. This is a molecule. Water is 2 different elements that are bonded together. So this is actually 3 atoms that make 1 molecule of water. It's 2 hydrogens and 1 oxygen. And then carbon dioxide, this is 3 atoms of 2 elements, because we have 1 carbon and we have 2 oxygens, and they're bonded together like this. Alright, so here is a common pure substance. This is chemically combined. These things that are showing that there is a bond between the oxygens and the hydrogens. So this cannot be separated because I can't physically pull it apart. It could come apart when I mix it with like an acid or a base or anything, but if I'm just changing it from frozen to liquid to gas, it's always going to look like this. This is pure water. So if I have a cup and I have a bunch of these in there, that is pure water. But when I take it from the tap, I might have some fluorine in there, fluorine. I might have some chlorine that helps disinfect. I might have some rust from my pipes. And that is tap water. So I'm not talking about tap water, I'm talking about pure water. Another pure substance that is bonded together, a bunch of elements that are bonded together, is sulfuric acid. This is an acid because it has hydrogens in it, and we'll talk about that later in the unit. But this has a sulfur element, 2 hydrogen elements, and 4 oxygen elements. And this is how they are bonded together. A cup full of sulfuric acid, this is pure. I cannot break that down anymore. Another common pure substance is bleach. You get this from the store, you use this to clean. It ruins your clothes if you get it on there, or your towels. This is NaClO, so sodium, chlorine, and oxygen. And they're bonded together here, and it's a bunch of those in this bottle. I cannot take the sodium or the chlorine or the oxygen away from each other. This is quartz. This is a common mineral that we find. This is pure, and you can tell it's pure because it has these really nice shapes that we call a crystal structure. And this is how a bunch of SiO2s silicon and oxygens, this is how they attach to each other. So they create a mineral structure. There is one silicon and there are two oxygens, and this is how they bond together. I can't take those apart. This is pure. And the last one is sugar. This is pure as well. It's just a bunch of little molecules in there. And look at how many elements make up one molecule of sugar. There are 12 carbons. There are 22 hydrogens. And there are 11 oxygens. All of these little lines in between the elements are bonds, and when those break, like our body breaks these down, a lot of energy comes out of these bonds inside. So that's why when we eat sugar, we get a lot of energy, because we're getting the energy from the broken bonds. Again, this is pure. I cannot take this apart anymore. It's combined chemically with chemical bonds.